This video is for Lesson 5 of the Pre-Algebra Math UC book, which talks about exponents. So first, right off the bat, what is an exponent? I do expect that you will have seen exponents before, but just like a refresher of what it is and what they look like here at the beginning. So an exponent is a way to represent repeated multiplication. Just like multiplication is the shortcut to do repeated addition, exponents are a shorter way to write or type into a calculator repeated multiplication. What it looks like is over here on this right side, this b to the x. B typically, and x actually, would both at this point in our math careers be numbers. But we call the normal size number, which is this b, we call that the base, and then the exponent part of it is smaller, usually half as big as like your regular font size or letter size that you use, and is up and to the right. We call this a superscript, which is random information you don't really need to know. But b is called the base, x is called the exponent, and if you want a way to read these, no matter what the numbers are, you would fill in the numbers to this phrase, b to the x power. So that could be 2 to the third power. I guess I should have somehow tried to make it like x power. That doesn't seem right. So 5 to the 7th power, or 6 to the 4th power, things like that. Now, it's also related to, and this is one of the things that is kind of neat about exponents, it's also related to dimensions. What do I mean by dimensions? I mean the idea that we have a certain number of directions we can go when we are in 2 dimensions, and a certain number of directions we can go when we are in 3 dimensions. We have shapes that are 2-dimensional, and we have shapes, well, I guess they're not called shapes, they're solids that are 3-dimensional, and there's a connection between those dimensions and exponents. And you might actually have seen this before. If you calculated area and done 10 meters times 10 meters, you end up with 100 meters squared. Now that word squared is what we use for the second power. We don't have to use it for the second power, but when you hear somebody use it, that's what you should think is second power. And then cubed is the third power. And so this is relating to dimensions because the second dimension would have squares and other shapes like that. And the third dimension, so think 3D, right, would have cubes, like ice cubes or things like that as shapes. So we're going to be asked to do a variety of things here. So starting off with label each diagram using a number with an exponent. So part of this is cool. Like if we're talking about squaring a number, then we could actually make a square out of the numbers. So we would look at, how many squares are this way? That's 5. How many are this way? That's 5. So we can write this as 5 squared. And you can maybe imagine, like, really long time ago, whenever they were first doing it, being basically like, we're going to take the 5 and we're going to square it. And they literally meant, think about it 2-dimensionally. 5 itself would be a 1-dimensional kind of a thing. But if we square it, we can make it be 2 dimensions. But that's what it wants you to do, is basically figure out what number squared is being represented here. There's also some that look like B, and I think they look kind of funny, but that's just, my opinion, because we still basically need to just count the sides. So this is 10, 11, 12. This is 10, 11, 12. If they weren't the same number on these two sides, we would not be able to write it with a squared. We had to have a square to write it with a squared. That feels like repetitive, but I mean, that's how it is. If you have a rectangle, it's not, you can't write it as a, we often call them perfect squares. If you try to make a rectangle or a square out of a certain number of blocks or whatever, if you end up with a rectangle, well, that's not a square. If you end up with something like this, that is a square, and we would call the number of blocks there, 25, a perfect square. And yeah, this may be information that we don't really need right at this moment, but I thought it was cool to share. Now, another thing we can do with exponents is actually figure out what number is being represented. So here's the kind of actual thing that's happening when I write 4 squared. Besides being able to think of it as a square, I can think of it as repeated multiplication, which means that I would say, well, 4 squared is if I multiply 4 together 2 times. So not 4 times 2, but I have only the number 4, and I'm multiplying it together twice. So 4 times 4, which is 16. Now, maybe that doesn't really make a ton of sense, or maybe you're going, why would I do that? But look at B. 2 cubed is asking us to do 2 times 2 times 2. It's asking us to multiply 2 together with other 2's, so such that we have 3 times that we've done it, or that we have 3 2's. So 2 times 2 times 2. The first 2 are 8. 4 times 2. Sorry, the first 2 are 4. 4 times 2 is 8. Got ahead of myself there. So the answer to that is 8. Now, what do you think about this next one on C? 1 to the 50th power. So that'd be 1, 2, 3. I'm not actually going to do it. And then it would go on until we have 50 of them. Now, obviously, I wouldn't ask you this if it was like 7 to the 50th power, because I'm not even sure your calculator would know how to do that because it's such a big number. But if we times 1 times itself, no matter how long we do that, we're still going to end up with 1, right? 1 times 1 is 1, and that's just going to continue to be the case as we multiply it more and more. So if you see 1 to any power, the answer to that will be 1. A similar situation here on D is if we have the first power. So if I have 9 to the first power, I'm saying multiply 9 together 1 time. But what that actually means is that we just have 1 9. We're not multiplying it by anything else, so it stays 9. So you can think of this basically as the exponent is showing you how many numbers you should be writing down to then multiply together. Now, how about fractions? When we multiply fractions together, like 1/6 times 1/6, which is what 1/6 squared would mean, remember that you times the tops together, which gives us 1, you times the bottoms together, which gives us 36. So our answer there is 1 over 36. So on E, okay, this one is the one we'll have to write down the most of these. So 2/3 times 2/3 times 2/3 times 2/3. Okay, so we've got it 4 times. And so then we need to do the tops, 2 times 2 times 2 times 2. And the bottoms, 3 times 3 times 3 times 3. And then we'll get our answer. And you may be going, well, this isn't shorter because I'm still having to write it out. At some point in time, you will probably feel comfortable, and it depends, it's a different time for everybody, but you'll probably feel more comfortable doing 2 to the 4th power and 3 to the 4th power without having to write it down, and that's what makes it end up being shorter. For instance, I know what 2 to the 4th power is off the top of my head, because this is 4, and this is 4, and then we can times those 4's together and get 16 on top. We can do something similar on bottom with the 3's, that this is 9, and this is 9, and then multiply them together and get 81. And if our original fraction didn't simplify, our ending fraction over here will not simplify either. So we don't even have to try to figure out what divides into 16 and 81, which is nice, because that would be annoying, because there's nothing. What else can we do with exponents? We could kind of work backwards and say, well, here's the answer to a problem that has an exponent. Fill in for me what the exponent is. So this actually relates to a much higher level math concept that I really like and has a great pun with it, and you're just going to have to stick with me until Algebra 2 to be able to find out what that pun is. So if I'm asking 3 to what power equals 27, I'm asking you to figure out how many times do I have to multiply 3 together before I get 27. So obviously, well, I don't like saying obviously. 3 is not enough, right? If I just have 3, so it's not 3 to the first power. 3 to the second power would be 3 times 3, which is 9. Still not enough. But if I times by another 3, 9 times 3 is 27. So the exponent here that's missing is a 3. So 3 to the third equals 27. Essentially, you may be having to guess and check, or you may be having to think about your multiplication tables or things like that. Like 8 to what power is 64? If you remember that 8 times 8 is 64, then you can go, oh yeah, that means there's 2 of them, so it's 8 squared. C, we have to do something even harder, which is count. And I say that not to make fun of you, but to make fun of myself because I'm bad at counting. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sevens, so this is 7 to the 8th. Don't try to actually figure out what that is, because that will take a lot of time and not have much value to it. And finally, we have a section here that says write with an exponent as a multiplication problem and as a whole number. So they are attempting to tell us about an exponential expression. So something to the something power. And so then we're going to write it as multiplication so that we can write it just as a regular number. 6 used as a factor 3 times means that we have 6, but we need it 3 times. That's what the word factor means, is that we're multiplying together the factor 6 3 times. So we start with 6 to the third power, and then we're going to say, okay, that's 6 times 6 times 6, which you may not have memorized, but I do. 6 times 6 is 36. And then I might come over here to the side and go, okay, what is 36 times 6? And I had been to, no, wait. Maybe I spoke too soon because I'm not sure that I was going to get that right. So 216 is the answer to 6 times 6 times 6, or 6 cubed. Let's see, B, 14 raised to the power of 1. I didn't necessarily mention that particular word because we could just say 14 to the power of 1 or 14 to the 1 power, first power, but raised is also a word you will see related to exponents. So 14 raised to the 1 power, that multiplication problem is just 14, and the answer is just 14. My numbers there look strangely fancy. C, 11 squared. Well, 11 squared is the same as 11 times 11. And if we know our multiplication tables with 11s, we know that 11 times 11 is 121. So that is lesson 5. Good luck. Thanks for watching. Bye-bye.